Program. I'm your host, Neil Howard, here on Health Professional Radio. Thanks for joining us again. In this segment, we're going to have a conversation with Dr. Jerry Silver. He's a professor of neurosciences at Case Western Reserve University School of Medicine and advisor to NerveGen Pharma. And he's joining us on the program to talk about NerveGen Pharma's spinal cord regeneration technology. Welcome to Health Professional Radio, Dr. Jerry Silver.
Yeah, thank you for inviting me.
Have you always been a neurosciences practitioner? Are you a neurosurgeon yourself?
Well, I'm a PhD, so I'm not a neurosurgeon. I'm a neuroscientist.
Okay.
And I've been studying spinal cord injury and regeneration for nearly my entire research career, which spans about over 40 years. I've been working on spinal cord injury for about 30.
Is it a personal endeavor? Why is that your specialty?
It's my passion. It's my goal. Once you get kind of hooked on this area of research, you kind of fall in love with it. Mm-hmm. Something I've always wanted to do. I've asked a lot of basic questions about why nerves don't regenerate after injury to the brain and spinal cord. But more than that, I'd like to actually take our knowledge that we've learned about basic questions and then apply that and help people. So that's my passion, and that's why I continue to do it. I won't give up. I'm not going to give up until we have something for people.
NerveGen Pharma, this spinal cord regeneration technology, are we into human trials of this technology? Is this something that's available? And is this regeneration technology something, because when you think of a spinal cord injury, you're thinking of being paralyzed, losing feeling, to limbs and whatnot. And the possibility of regaining that mobility and function is phenomenal, just the possibility. Yes. So is this what we're talking about?
Yes, we are. So to answer your first question, is this going to be available soon? I can tell you that the company is planning to begin clinical trials, and that's phase 1, safety trials, in early 2020. So it's going to start soon. But those are safety trials to see, the best route of administration and is the drug safe in people? It's worked great in animals so far, and so the next goal is to start real clinical trials. And yes, they're starting, but it won't be available for a while until, of course, the FDA approves the trials all the way through its various phases. And the idea is to try to fix the spinal cord after injury, not only at acute stages, but also at chronic stages after spinal cord injury. And we have figured out a way to overcome the scarring that occurs after injury to the spinal cord that blocks nerve regeneration. So we've developed a very small peptide that's given systemically. You don't touch the spinal cord. After you're injured, you're simply injected once per day. At least that's what we did with the animals. You inject once per day under the skin, just above the lesion in the back. So under the back skin, and then over time, with proper doses, the recovery in our animal models of spinal cord injury has been unprecedented. Really spectacular recovery.
So let's talk about some of the severity of the test subjects. Now, we are talking about rodents. Are we talking about larger animals?
Yeah.
Rats?
Yeah, we're talking about rats. So fully adult white rats. Mm-hmm. Those are the animal model that we use. The spinal cord injury in a rat pretty closely mimics that which occurs in a human. Mm-hmm. So these are fully adult rats.
We're in these trials with these rats. We actually saw regeneration of the nerves to the extent that paralyzed subjects were able to walk again, or at least have movement in their limbs.
Yes, not just walk again, but almost actually remarkable recovery. In our early work that was published in a journal called Nature in 2015, the animals that we paralyzed, these are fully adult rats, were moderately paralyzed. So they could not take a weight-bearing step, and they had no coordinated walking, but they could move the joints a bit. There's a rating scale that was developed at The Ohio State University that scores the animals from 0, which is completely paralyzed, nothing, to 21, which is normal walking. And our animals started at a score of 10. So that's moderately paralyzed. So the animals can move their limbs, but they can't take a weight-bearing step. And in response to our treatment, the animals gained 6 points on that scale, which allowed them to take coordinated steps. The work was replicated independently from my lab by a group in Germany just last year, and they created spinal cord injuries that were far more severe than ours. So their animals baselined at a score of 6, which is very extremely paralyzed. Not completely, but just the ability to barely wiggle the limbs. And they treated the animals with far greater doses, 50 times more than we used. And their animals, on average, gained 9 full points on this walking scale. And that was all the animals taken as a group. And their responding animals, which were at about 70% of all the animals, gained a miraculous 12 full points of recovery, which is 6 to 18, which is almost normal walking. So this is really unprecedented, and that's why we're so excited to move forward, in clinical trials in people.
As far as the doses that you were administering here versus the doses that were being administered there, what type of time period are we talking about from, say, moderate paralysis to that 12 on the scale that you just talked about?
Right. So the animals are paralyzed by traumatic injury that's replicated from animal to animal. So the lesions are replicable and repeatable. And the drug is administered starting a day after the injury. So you wait a day so you could get to the hospital. And then once per day for 7 weeks, the peptide, this drug, is administered once per day under the back skin. And the German group did it exactly the way we did. And then the dosing stops. But the animals continue to get better for multiple weeks after you stop injecting. So for several months afterwards, they continue to improve until they get to that 12 in the German case. And so about 7 weeks of injection.
About 7 weeks of injection. And were there any, notable effects as far as once the dosage was stopped? Was there sustained mobility and weight bearing, or was there a reversal of some type?
Yeah, good question. It turns out that once the animals improve and achieve their higher score, that score is maintained. So for the rest of the life of the animal. So once they're improved, they stay that way. So all the new connections that are made after we deliver the drug are sustained and not eliminated. So good question. So they continue to look to be just fine. And not only do the animals walk better, but they also can use their bladders better. So not only was there improvements in walking, locomotor activity, but also urination. Problems with bladder function are very important in spinal cord injured people. That's one of the autonomic problems that they developed, among lots of other problems. And we saw really nice improvements in bladder function. So not only walking, but also bladder, which is really great.
Where can we go and get some more information about your research, maybe see a video or two, and keep track and learn more about the upcoming Phase 1 clinical trials that should be just over the horizon early next year?
Yes. So there are two routes of information seeking. that your listeners could attend to. The first is to just put my name, Jerry Silver, into a Google search and do YouTube, and multiple seminars and lectures that I have given will pop up. And so you can actually see me, and I give thorough descriptions of the research. So that's one way. A second way is to go to the NervGen, NERVGEN website, and there are descriptions of the work there as well. But I suggest kind of a YouTube exploration. You can see me, deliver seminars. They last somewhere between a half an hour and 45 minutes, depending on which one the person picks.
Well, I thank you for joining us here on the program, here on Health Professional Radio, Dr. Silver, and I'm hoping that we'll talk again, especially as these trials get underway early next year.
Yes, thank you for inviting me, and I appreciate talking with you.
You've been listening to Health Professional Radio. I'm your host, Neil Howard. Transcripts and audio of this program are available at hpr.fm and healthprofessionalradio.com.au. You can also subscribe to the podcast on iTunes, listen in, download at SoundCloud, and be sure and subscribe to our YouTube channel at youtube.com, Health Professional Radio.
The spinal cord is the body's information superhighway, constantly buzzing with electrochemical signals between the brain and the rest of the body. This precious bundle of nerve fibres runs through a cavity within each vertebra,